On October 11, 1968, Apollo 7 lifted off from Cape Kennedy Air Force Station Launch Complex 34 aboard a Saturn 1B rocket, marking the first crewed flight of NASA's Project Apollo. Just 278 days later, the fifth crewed flight occurred. Apollo 11 aboard a Saturn V launched from Kennedy Space Center Launch Complex 39A, which would put the first human beings on the surface of the moon. 278 days, 9 months, 5 crewed missions, 5 launch vehicles, 10 crews. Project Apollo moved at a breakneck speed, unmatched by any other space program before or after it. The entire nation came together to honor John F. Kennedy's promise of a man on the moon before the decade was out. It's impressive and a little mind-boggling, the logistics of managing these 5 tightly packed missions, so today, we're going to break down just how much went into this excessively busy period down at the Cape. So strap in, face forward, pointy end up, flamey end down. In order to talk about the intensity of this pace of the later portion of the program, we have to talk a little bit about how it reached that point. I swear, every time I make an Apollo-era video, it snowballs and I have to go back way further than I intended to. There's a little joke in the space community that when someone asks you why they retired the space shuttle, you have to start with, well, in 1972, when Apollo 17 was landing on the moon, this guy named Richard Nixon. Anyway, the Apollo program did not begin as the ambitious and fast-paced lunar crash program that it eventually became. It was conceived in early 1960 as a follow-up to Project Mercury. While the intention of Mercury was to prove the feasibility of going to space, Apollo would prove the feasibility of working in space. In July of 1960, Hugh Dryden, Deputy Administrator of NASA and Director of NACA, the agency's predecessor, made an announcement to the Space Task Group, the early managers of NASA's human spaceflight programs. Project Apollo was laid out, with goals of a 3-person spacecraft that included a mission module which was separate from the piloting and re-entry cabin, as well as a propulsion and equipment module. NASA offered up the Apollo spacecraft feasibility study, offering $250,000 contracts to companies that could offer up proposals for post-Mercury spacecraft. These crafts would need to be robust enough to perform several functions, work as ferries to an orbital space station, perform flights around the moon, and eventually land on the moon. After some time, 3 contracts were awarded, to General Dynamics/Convair, General Electric, and the Glenn L. Martin Company. At the same time, NASA performed their own in-house feasibility study, headed by Maxime Fazet, who designed the Mercury spacecraft among other things, intended to be a gauge of how well the competing companies were doing. However, after all 3 companies submitted their widely varying proposals, NASA decided to discard all 3 in favor of their in-house design, because very suddenly, the pressure had been placed upon NASA and Project Apollo both by the country's new president John F. Kennedy and by the actions of the Soviet Union. Kennedy ran a campaign that leaned heavily on American spaceflight. This was an industry born out of the missile gap, and out of the fears of nuclear exchanges between the 2 countries. At the end of World War II, the United States seemed to be in a position of superiority with air power. The U-2 spy plane gave them a serious edge in being able to monitor Soviet nuclear weapons activity, and the B-52 and similar aircraft provided ideal nuclear delivery systems. However, the Soviets then developed the R-7, the first intercontinental ballistic missile, and the tables seemed to turn. The USSR was now capable of delivering a nuclear payload to practically any location across the planet from Russia, and there seemed to be little that could be done to stop them. JFK spoke heavily on this during his campaign, emphasizing a need for the US to close the missile gap and develop their own long-range systems. At the same time, he talked up the dual purpose of missile systems. The launch of Sputnik 1 in 1957 had opened a brave new world. Satellites had potential for reconnaissance and communications, and also displayed the possibility for human spaceflight. He stated that the inaction of the Eisenhower administration had created the missile gap, which, by the way, kinda didn't really exist at the end of the day, but makes for a great campaign talking point, and that aerospace technology should be a symbol of national pride, of prestige over the Soviet Union. He proclaimed that the United States should not be, quote, first but, first and, first if, but first period.
The space program stands on its own as a contribution to national strength. And last Saturday at Cape Canaveral, I saw our new Saturn C-1 rocket booster, which with its payload, when it rises in December of this year, will be, for the first time, the largest booster in the world, carrying into space the largest payload that any country in the world has ever sent into space. That's what I consider.
Despite all of the rhetoric, Kennedy didn't immediately push Project Apollo into motion following his election. After Yuri Gagarin made his first orbital flight on Vostok 1 in 1961, Kennedy sent Vice President Johnson to look into the state of the US space program and find out just how behind they were. About a week later, Johnson reported back. The situation was not good. He stated, quote, "We are neither making maximum effort nor achieving results necessary if this country is to reach a position of leadership." The memo concluded with a suggestion, primarily urged by Wernher von Braun, director of the Marshall Space Flight Center, that a crewed lunar landing was a distant enough goal that the United States had the time to reach it and beat the Soviets to it, putting them in the lead of the then burgeoning space race. In May of 1961, Freedom 7 launched, putting the first American, Alan Shepard, into space, for about 5 minutes. While Gagarin's flight had been a full loop around the Earth in an orbital path, Shepard had simply hopped above the Kármán line for a few minutes and then fallen back down on a ballistic trajectory. It was now clear to the public that America's space program was lagging behind. 20 days later, in an address to Congress, Kennedy made his big statement.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Project Apollo now had its official goal and a deadline. Before 1970, NASA had to put a man on the moon. It was now that the explosion of activity began. NASA dropped the feasibility studies and began to develop the Commanded Service Module from Maxime Fazet's design, which saw the mission module as unnecessary space and therefore dropped it. This in-house design was the basis for another contract competition, which was eventually awarded to North American Aviation. At the same time, the Marshall Space Flight Center, which was working on the Saturn series of rockets under von Braun's direction, was given new direction, new funding, and urgency. In the next year, the Manned Space Flight Center was founded, today called the Johnson Space Flight Center. It had become clear that the Space Task Group was no longer sufficient for managing crewed spaceflight out of NASA's Langley Research Center, and a new center was needed, with Houston chosen for a location, and plans for a new Mission Control Center were included. By now, Kennedy had reiterated his promise of sending Americans to the moon. At Rice University in Houston, he gave a speech to bolster support for the American space program. He painted space and the moon as a beckoning frontier, one that America could conquer with an already pioneering spirit.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
He instilled a dream in his audience, and while public support for Apollo would be up and down throughout its existence, this speech would be remembered for generations to come. Apollo was growing bigger, far too big for the Cape Canaveral launch sites, which have had quite literally 8 different names throughout their existence, alone. 2 new launch sites for the Saturn I and Saturn 1B had already started construction, but the Titanic Saturn V would need even more, resulting in the Launch Operations Center, now known as the Kennedy Space Center, which included the massive vehicle assembly building, allowing launch vehicles and their spacecraft to be integrated and then brought to the pad on a mobile launch platform. Launch Complex 39 was constructed with remarkable speed. Groundbreaking took place on August 2, 1963, and Pad 39A was finished in October of 1965, while 39B was finished in July of 1966. NASA Administrator James Webb realized that Project Apollo was going to require some serious project management skills to keep costs under control and keep operations on schedule, so he recruited George Mueller, then an engineer who was in charge of missile development at TRW, into the position of Associate Administrator. Mueller agreed only on the condition that he would be able to have a say in reorganizing NASA, and by 1963, the Manned Spacecraft Center headed by Gilruth, the Marshall Space Flight Center headed by von Braun, and the Launch Operations Center headed by Kurt Debus would all report directly to Mueller. Mueller, realizing he would also need a skilled manager of his own, recruited General Samuel C. Phillips of the U.S. Air Force, who had been key to the Minuteman ICBM program, naming him Apollo Program Director. In 1962, Deke Slayton was made Director of Flight Crew Operations. The only member of the original Mercury 7 astronauts who had never flown in space due to a heart murmur, Slayton would be responsible for crew management throughout Project Apollo and Project Gemini, conceived in the previous year. Astronaut Groups 2 and 3 would contain all of the new astronauts needed for Apollo except for one, Harrison Schmitt, who was from Group 4 and would fly on Apollo 17. NASA had no issues finding candidates at this point. Group 2, selected in 1962, contained a lot of applicants who had applied for the Mercury 7 but been rejected simply due to the small number of astronauts needed. Height requirements were also relaxed due to the larger spacecrafts of Gemini and Apollo, as well as civilian test pilots being applicable, leading to the selection of Neil Armstrong, among others, who was already flying for NASA in the X-15 program. Group 3, announced in the next year, would further relax the requirements by removing the test pilot requirement, though military fighter jet experience was still needed. Deke Slayton foresaw an attrition rate that might leave NASA with a shortage of astronauts, resulting in Group 3 adding another 14 to the roster. However, out of this third group, 4 would unfortunately die in training accidents, 1 in the Apollo 1 fire and 3 in T-38 training jet crashes. While the Saturn rockets were being developed, NASA managers debated endlessly about the mission mode for landing on the moon, with 2 options being at the forefront: direct ascent and lunar orbit rendezvous. Direct ascent was considered favorable. 1 spacecraft would be used to launch, reach the moon, land on it, and return to Earth. Lunar orbit rendezvous would involve sending 2 spacecraft simultaneously: a command module for lunar orbit and return to Earth, and a lander that could be discarded after surface operations. Direct ascent was considered simple and safe, but expensive and heavy, requiring the development of the Saturn C8 or Nova rocket, a much larger vehicle than the Saturn V. Lunar orbit rendezvous offered significant weight and cost reductions, but required specialized rendezvous and docking skills that had not yet been developed. Hence, as a result, the 2-man Gemini program now had a more cohesive goal outside of multi-crew flights: develop those skills. Gemini would run concurrent with Apollo, achieving rendezvous, docking, and performing spacewalks, and at the same time, the Saturn rockets began large-scale testing. In November of 1963, another event occurred that would further spur on the determination of the Apollo program and the American people. President John F. Kennedy was assassinated in Dallas, Texas. The Launch Operations Center was renamed via an executive order from Johnson to the Kennedy Space Center. Now, Americans had a promise to keep. Kennedy had declared the goal and promised it would be done. It was up to NASA and everyone behind Project Apollo to keep that date. Development of the Apollo vehicles following Kennedy's death was significantly delayed. In 1965, Mueller and Phillips headed up a team to investigate problems within North American aviation, attempting to streamline the design of the Block 1 CSMs. This was delayed further after the disaster of Apollo 1 claimed 3 astronaut lives in early 1967, leading to further restructuring of both North American aviation and NASA management. However, it did little to slow the program down. NASA took the time to human rate the lunar module and the Saturn V, launching Apollo 4 in November, which would also qualify the CSM heat shield for re-entry.
Liftoff. We have liftoff at 7 a.m. Eastern Standard Time.
At liftoff, 7,500,000 pounds of thrust is unleashed from the first stage's 5 immense Rocketdyne engines.
Apollo 5 in January of 1968 then qualified the LEMS abilities, testing both of its engines and its abort sequence. Apollo 6 in April then attempted to test translunar injection and a simulated return abort from the moon, but serious problems with the Saturn V caused the flight to fail the vast majority of its objectives, including restart of the third stage for the injection burn. Shockingly, NASA declared the Apollo program ready for crewed missions based on the performance of Apollo 5 and the fixes designated for Apollo 6. The pressure was on, the decade was almost out, and now the program would have to truly fly by the seat of its pants to achieve its promised goal. George Mueller laid out a schedule and a series of mission categories, and with each flight, this schedule and list of categories would be whittled down, streamlining the process and bringing Boots closer and closer to setting foot on the moon. I'm just going to note quickly that I have very much paraphrased these early years of Apollo. I could absolutely make a more detailed video regarding all of the organizing and building and preparation that I've just skimmed over, if people are interested in seeing it. I swear, I could talk about Apollo for the rest of my YouTube career and never run out of material. I'm also going to add one other thing. Apollo safety standards were truly something else. Obviously, extreme oversights were corrected once they became apparent, such as those on Apollo 1, but it will never not amaze me that Apollo 6 nearly shook itself to pieces on launch, yet the decision was still made to fly crew on the very next Saturn V. The LM on Apollo 5 experienced significant difficulties, aborting its own engine burn repeatedly and ending up spinning out of control due to a guidance failure after the main objectives were completed. But again, crew would fly on the very next LM to reach space. These kinds of standards could never be met today. Look for instance at the spectacle over the Starliner spacecraft. It returned home from its crewed test flight safely, but the crew were still kept on the ISS just in case. In the days of Apollo, not only would crew have been on the second flight rather than the third, but they would have come home with that third spacecraft. Mueller's categories of missions were named A through J, and he stated that each mission type would have to be achieved before the next to successfully perform a lunar landing, though the first landings would actually occur at the G missions, not the J missions. A and B were validation of the Saturn V and the spacecraft, which were achieved with Apollo 4, 5, and 6. Barely. Next was C, a crewed flight demonstration of the Command and Service Module in low Earth orbit, Apollo 7. Deke Slayton decided the crew back in 1966 before the Apollo 1 fire. Mercury and Gemini veteran Wally Schirra would command, with Don Isley as command module pilot and R. Walter Cunningham as lunar module pilot, though the flight wouldn't actually include a lunar module. Their backup crew were John Young, Gene Cernan, and Tom Stafford, who would later be assigned to Apollo 10. The crews for Apollo all worked support roles when they weren't assigned as direct or backup crew members, keeping them ready, up to date, and sharp for the days when they would sit in the seats. For Apollo 7, 3 future astronauts were assigned support roles, or rather, what was hoped to be 3 future astronauts. Ronald Evans was involved in hardware testing at KSC and would eventually go on to fly Apollo 17. Jack Swigert performed capsule communicator or Capcom roles at Mission Control and would fly Apollo 13, and Edward Givens initially worked on modifying procedures, but would be replaced by William Pogue after Givens sadly passed away in a car accident. Pogue would eventually be part of the third and final crew of Skylab. Schirra, Isley, and Cunningham worked long hours in preparation for Apollo 7. The fire had left astronauts with little to no trust in North American aviation, and they followed their spacecraft, the first Block 2 Command and Service Module, through every step of its construction and testing. At the same time, they had training and simulators to do, forcing them to work 12 to 14 hours a day most of the time. In addition to simulators, they undertook training for evacuating from the launch pad, water egress training, firefighting training, as well as attending technical and pilots briefings. Even though their command module had been extensively redesigned to prevent the issues of Apollo 1, they still conducted their own plugs-out test with the hatch door open, just in case. The hardware was also extensively tested in the run-up to Apollo 7, in addition to the intense training of the crews. An entirely different crew spent 8 days inside a CSM while within a thermal vacuum chamber to test its ability to withstand the rigors of space. Another crew spent 2 days aboard a command module that had been submerged into the Gulf of Mexico to test its responses to seawater exposure. Fires were intentionally set inside boilerplate spacecraft to better assess environmental controls, leading to the decision to have a 60-40 oxygen-nitrogen atmosphere at launch inside the cabin. Other boilerplate spacecraft were dropped and parachute tested to assess their ability to make landings on hard terrain, with all results considered satisfactory. During preparation for Apollo 7, the pressure was applied even more heavily. In March of 1968, the Soviets launched Zond 4, an early uncrewed attempt at a Soyuz-based circumlunar flight. It didn't go very well. It wasn't actually launched on a flyby trajectory, and its guidance system failed on re-entry, leading to its destruction some 10 to 15 kilometers above the coast of Guinea. Zond 5, launched in September, was more successful, carrying a pair of turtles around the moon on a successful flyby and returning them safely to Earth. From the US point of view, it looked like the Soviets were getting ready for crewed lunar flights and were in fact making progress. George Low, the Apollo program spacecraft manager, proposed an alteration to the established mission flow. If Apollo 7 was successful, they would forgo waiting to send a lunar module to the moon on the next flight, as the LM was experiencing significant delays. The pressure for Apollo 7 was on. Apollo 7 would be the final launch from Launch Complex 34, one of the old Air Force launch centers. The previous rocket to sit on this pad was the one used for the tragic plugs-out test of Apollo 1. Because of this, Apollo 7 would be the only flight to not make use of the mobile launch platform, though the third MLP was finished and ready for use by 1965. LC-39, however, was being prepared for Apollo 8 at the time, so the existing architecture at LC-34 would be used for one last time. The first stage of Apollo 7 was transported and erected on the pad using the service tower that was capable of rolling back away from the pad, while the second stage was integrated with the spacecraft, then rolled out to the pad to be mated to the booster while it was there. By Friday, October 11th, the first crewed American spaceflight in 22 months was ready to lift off. Or was it? Let's talk again about safety standards for a moment. While Apollo 7 was counting down, wind was blowing in from the east, the direction the vehicle would be launching towards. This was dangerous because, in the event of a failure in Abort, the winds could blow the parachutes of the capsule back over land. While it was tested to survive a hard landing, it likely wouldn't be a very safe landing, as this capsule featured the old couch-style seats used on the Block 1 command module. Technically, these winds violated the launch conditions, and Schirra was well aware of this, stating later that he believed the launch should have been scrubbed. However, managers waived the rule, caving to pressure and launching anyway.
Ready to go. Coming up on the 10-second mark. 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition. Commit liftoff. We have liftoff. This is launch control. We have cleared the tower.
Roger, tower clear. 12 seconds out and the roll program has commenced.
Thankfully, the launch went smoothly, placing the vehicle and crew into orbit, and the crew immediately went to work achieving their testing objectives. An early goal for assessing the spacecraft's capabilities was achieved before separating from the S-IVB. Since a translunar injection burn would require aiming the upper stage and spacecraft together, they practiced at this, using its RCS thrusters to adjust its orientation. Once they had succeeded at this, the spacecraft separated from the S-IVB, the spacecraft lunar module adapter or SLA pedals opening up to allow it to float free. They then turned the CSM around and aligned it with a docking indicator inside the SLA, practicing the transposition and docking maneuver that would be required on full lunar missions. The SLA pedals only opened partially, similar to an incident with the Agena target vehicle on Gemini 9A, and if there had been an actual lunar module inside, this could have been a real problem. Subsequent missions modified the pedals to be jettisoned entirely after the CSM separated from them, making this the only time an S-IVB ever looked quite like this. After practicing the docking maneuvers, the upper stage was allowed to drift away about 120 kilometers so that it could later be used as a target for rendezvous. Around this time, Apollo 7 started to get a little rough. By the end of the first day, Schirra reported that he had a cold. Mission Control was adding items to an already tightly packed schedule, and when the crew was asked to test the television camera earlier than expected, the tired, sick, and frustrated Schirra put his foot down. Quote, "You've added 2 burns to this flight schedule, and you've added a urine water dump. We have a new vehicle up here, and I can tell you at this point, TV will be delayed without any further discussion until after the rendezvous." Slayton protested that they weren't doing an actual broadcast, merely powering up the equipment. However, Schirra stuck to his guns. Quote, "We do not have the equipment out, we have not eaten, and at this point, I have a cold. I refuse to foul up our timelines this way." When the first television broadcast did occur, the astronauts appeared to have a smiling and sunny disposition. They held up cue cards with cheerful messages to the public such as, "Keep those cards and letters coming in, folks." When the broadcast ended, the astronauts had successfully delivered a public relations coup, keeping quiet the conflicts and turmoil that were plaguing the mission. The rendezvous itself, taking place on October 14th, was one hell of a task. The Apollo 7 spacecraft didn't have a rendezvous radar, which later missions would have. All of the computations for making rendezvous burns with the service propulsion system would be done from the ground, but once they got close, the astronauts would have to make the final, more subtle adjustments using a telescope and a sextant. The SPS engine itself had only ever been fired on a test stand, and everyone was a little worried about how it would function in the moment. However, it wound up being entirely successful, even perking up Schirra's spirits enough that he shouted "Yabba Dabba Doo" when the SPS ignited for the first time, and the craft was able to successfully prove that a rendezvous with an LM that had aborted its lunar mission could be performed. When the crew splashed down and were recovered, they were praised for their efforts in mounting monumental first-time tasks. Despite the difficulties and disagreements, nobody was upset with Schirra's stern leadership, in fact using the disagreements to better fine-tune how crews and mission control would communicate in the future. Apollo 7 was a success, which meant the modified mission of Apollo 8 was ready to commence. Just a month after the splashdown of Apollo 7, it was announced that Frank Borman, Jim Lovell, and William Anders would be the crew for Apollo 8. Apollo 8 was originally intended to be a D mission, a test of the lunar module in low Earth orbit, but the LM continued to be behind schedule. The success of Apollo 7 led to a proposed redefinition of the alphabetical categories. Now, instead of repeating the C-type mission of Apollo 7, Apollo 8 would now be a C' mission, a demonstration of the Apollo CSM in lunar orbit that would eliminate the need for the later E-type mission, which was a demonstration of the CSM and LM in high Earth orbit, performing the transposition and docking necessary for landing. Now, there would only be 3 steps remaining: fly the CSM to the moon, Apollo 8, fly the CSM and LM combo in Earth orbit, Apollo 9, and do a dress rehearsal of the whole landing, Apollo 10. In August, Deke Slayton flew to Marshall along with flight director Chris Kraft to speak to Kurt Debus, Werner von Braun, and others regarding the readiness of a crewed Saturn V. Debus was confident that AS-503, the next Saturn V, would be ready in time, and von Braun was confident that the pogo oscillation problems that had plagued Apollo 6 were effectively solved. They returned to bring the final proposal to James Webb, who was hesitant but eventually agreed that a crewed circumlunar flight could provide a significant morale boost, and with the full support of the rest of the agency's management, approved the changed flight schedule. The astronauts, however, were less enthused about this. Due to the change in mission profile, Slayton asked James McDivitt, the original mission commander, if he still wanted to fly it, and McDivitt declined. His crew had devoted all of their time to learning to fly the lunar module, and so he and his crew were instead moved to the next flight so that they could do exactly that. Slayton then switched the prime and backup crews for the D and E missions, which also meant swapping spacecraft, which both crews were unimpressed with. With each crew closely following the construction and testing of their intended craft, they wanted to use the ones originally intended for them. Furthermore, William Anders was less than impressed with suddenly being the lunar module pilot on a mission that had no lunar module. Instead, since it was going to the moon anyway, Apollo 8 would carry a boilerplate model which would simulate the size and weight of an LM, allowing the S-IVB to make an accurate injection burn toward the moon. Meanwhile, while the crews were rearranged and continued training, work was done on the Saturn V. After the near disaster that was Apollo 6, it was believed that the next Saturn V would be flying another uncrewed test flight when it was erected in the vehicle assembly building. Management was generally of the opinion that the Saturn V could not be declared ready for crewed flights without at least one more uncrewed test with boilerplate spacecraft. Marshall engineers worked tirelessly, implementing a solution for the oscillation problem in the form of a helium gas absorption system and reworking the fuel lines to address the previous flight's engine failures. An S-1C and a modified S-4 from a Saturn 1B were tested on a stand to demonstrate fixes, convincing management to approve the flight of AS-503, though the testing didn't stop. The rocket was rolled to the pad on October 9th, and testing continued all the way through December, with the final testing of modifications to fix the pogo problem being just 3 days before the launch. Apollo 8 lifted off from Launch Complex 39A on December 21, 1968, and the Saturn V performed relatively flawlessly, with the S-IVB performing the injection burn on time and without issue to propel the vehicle toward the moon.
At 7:51 a.m. Eastern Standard Time. We have cleared the top.
Tower clear, 13 seconds.
The CSM separated and turned around to get a look at the spent upper stage, practicing flying in formation with it, and getting the first look at a whole Earth that human beings had ever seen with their own eyes as they sped away from it. Some deliberation about how best to perform a small burn to separate from the S-IVB and the CSM put the crew behind a little, though they quickly caught up during their 6-day mission. The crew performed navigation tasks and course correction burns, and Frank Borman fell ill after taking a sleeping pill, suffering a bout of vomiting and diarrhea that left the command module with floating globules of, let's call it organic material, that the crew cleaned up as best as they could. Borman was quiet about his illness to mission control, and it was later believed that he was suffering from space adaptation syndrome, basically the space version of motion sickness. While fairly common today and still suffered at least briefly by around half of astronauts, at the time it was a relatively unknown issue. Mercury and Gemini astronauts didn't have much freedom of movement, so the issue only really cropped up in the roomier Apollo capsules. Before we continue with this first lunar mission, let's pan the camera back down to Earth. Consider for a moment the sheer amount of work that went into launch pad preparation. Consider that just minutes ago, a Saturn V launched from pad 39A. The entire area has been scorched, fires lit, concrete and metal fragments flung in every direction, and every part of the pad and mobile launch platform have been subjected to incredible amounts of stress from vibrations. Fire suppression systems would be activated to cool the pad and remove any remaining fires and hotspots. Crews would then arrive to clean up debris and inspect every inch of infrastructure. The flame trench, especially susceptible to concrete damage, would be carefully inspected and repaired. The mobile launch platform would have its umbilicals inspected, the hold-down arms, the overall structural integrity, undergoing repairs and sometimes replacements. Any spillage of rocket fuel or other corrosive chemicals would have to be carefully cleaned up as well. Finally, crews would then begin preparation for the next launch, repainting, recalibrating equipment, reinstalling or adjusting support systems, and detailed post-launch reports would have to be compiled to improve preparations in the future. This process took time. This is why there was more than one pad. While the cleanup from Apollo 9 was being done on Pad 39A, Apollo 10 was being prepared on Pad 39B. The crew of Apollo 8, meanwhile, entered lunar orbit by performing a burn from the far side of the moon, as that's where one needs to be done on a flyby trajectory, meaning they had to be out of contact with mission control. The minutes of darkness were nerve-wracking for mission control, though they did have a way to be sure the burn was achieved. If it wasn't, the craft would appear earlier from the other side of the moon due to moving faster, and when this didn't happen, mission control was confident that they had succeeded. Apollo 8 re-established contact exactly on time, now in a slightly eccentric lunar orbit of around 311 by 111 kilometers, later circularized to around 112 kilometers even. The crew spent 20 hours doing 10 laps around the moon, examining the surface, taking photos, and taking note of how the moon altered their orbit. Despite being roughly spherical, the moon has an uneven distribution of mass, which causes orbits around it to change over time. What was initially a circular 112-kilometer orbit became, at the end of their mission, around 117 kilometers. At some point during Christmas Eve, the crew took the iconic Earthrise photo as the planet became visible over the lunar horizon. Afterwards, the crew broadcast back to Earth a reading from the Book of Genesis covering the first 10 verses.
In the beginning, God created the heaven and the earth. And the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. And God said, "Let there be light." And there was light. And God saw the light, that it was good, and divided the light from the darkness.
Apollo 8 returned to Earth after a fully successful mission on December 27, 1968. The year had closed out with a crucial step toward the moon, and now the extreme pace of the program could continue just long enough to reach Kennedy's goal. After Apollo 8 eliminated the need for an E-mission in high orbit, Apollo 9 now had the goal of qualifying CSM-LM operations in low Earth orbit. Could a lunar module maneuver and dock to the CSM? Could a Saturn V successfully launch both vehicles? Could the lunar module successfully use its propulsion system with a crew? This, as well as several other factors, some very important to the later program, would all be tested on Apollo 9. The crew, James McDivitt, David Scott, and Russell Schweikert, were considered among the best trained out of all Apollo astronauts, as they had originally been intended to follow up Apollo 1 and had been in training ever since the fire with roughly the same mission goals the entire time. Their training featured more extensive experience with weightlessness and underwater EVA training, as Apollo 9 would feature the first spacewalk of the program. The hardware for this mission featured several changes in design. The Saturn V was upgraded slightly for its increased payload, as the early lunar modules were somewhat heavier than those that would perform actual landings. The F1 engine chamber in the first stage had parts of its inner core removed to increase specific impulse, the J2 engines used a closed-loop propellant system that also increased specific impulse, and overall weight was saved by making the fuel tanks thinner than ever before. The lunar module flown for this mission was LM-3, switched out from the originally planned LM-2. When LM-2 had come off the production line, the crew looked it over, finding numerous flaws with it. Many of these were considered a result of it being the first flight-ready LM to be produced, and the switch in missions after the success of Apollo 7 afforded them a little extra time to wait for the next LM. The crew was far more satisfied with this second lander, and LM-2 would never fly in space, eventually finding its way to the National Air and Space Museum in Washington, D.C. Apollo 9 was the first Apollo mission that allowed astronauts to name their spacecraft. The last time this occurred was on Gemini 3, when Gus Grissom decided to nickname his spacecraft the Molly Brown, after the Titanic crew member who would go down in history as the unsinkable Molly Brown. NASA management wasn't fond of this name, especially after Grissom joked that he could instead just name it Titanic, and forbade future crews from naming their vehicles. However, Apollo 9 would use two vehicles, and the crew needed a way to differentiate the two in communications. Thus, the Apollo 9 CSM was named Gumdrop, while the LM was named Spider, both names a reflection of their physical appearances. NASA still didn't like the informal nature of the names, requesting that future crafts have more professional designations. We'll see about that. Apollo 9 began about a week late. All 3 crew members had colds, and the spacecraft were kept at a constant readiness level while they recovered, costing about $500,000 to do so. It would finally lift off on March 3, 1969, from Launch Complex 39A, and while the first 2 stages were found to slightly underperform, the S-IVB compensated and the crew was successfully placed into an orbit of around 160 kilometers.
Sequence start. 6, 5, 4, 3, 2, 1, 0. All engines running. Commit. Liftoff. We have liftoff at 11 a.m. Eastern Standard Time.
At 2 hours and 41 minutes into the mission, the real work began. The CSM was separated from the S-IVB and turned around to dock with the LM, which was nestled inside the SLA atop the upper stage. The docking, performed by Scott, went flawlessly, and after the tunnel connecting the 2 craft was inspected, the S-IVB was separated. The SPS engine was fired to ensure the lander would remain attached during a burn, and it did, which Scott reported back to Mission Control very excitedly. Following this, the S-IVB was fired again, descended into a solar orbit, and the astronauts were scheduled some time to sleep. Bizarrely, they would later complain that they kept getting woke up by accidental transmissions from non-English speakers, possibly speaking in Chinese. The origins of these transmissions were never exactly nailed down. The second day was spent performing different SPS burns, ensuring every aspect of it worked correctly, including gimbaling the engine to ensure the autopilot could dampen the oscillations gimbaling would create, which it did. The third day had a very essential task, firing the descent engine of the lunar module to ensure it could move and steer both spacecraft, which would eventually become key for saving the crew of Apollo 13. As they would be unable to ensure safe use of the SPS for course corrections following the explosion, they were forced to use the LM's engine instead, and Apollo 9 proved that such a thing would be possible. It was around this time that space adaptation syndrome reared its ugly head again. The crew had been avoiding sudden movements for exactly this reason, but now they had to don their spacesuits to do a checkout of the LM interior and its status. This required them to make twisting motions with their hips, and first Schweikert, then McDivitt began to feel queasy. However, the crew felt an immense sense of duty to succeed in their mission and keep the program on time for its goal. They continued with the LM checkout, marking the first time a crew ever directly transferred between 2 vehicles. The Soviets had performed a crew transfer with Soyuz 4 and 5, but had needed to do an EVA to get from one vehicle to the other. They closed the hatches between the 2, testing the LM's independent communications as well as deployment of the landing legs, which sprang out on command. The checkout finished with firing the LM engine, simulating the firing pattern used for descent toward the moon's surface. Day 4 performed another critical task. Schweikert, still aboard the LM, was to exit Spider via the hatch, donning the life support backpack for the first time, and ensure he could re-enter Gumdrop via its hatch. This was the only time an EVA would be scheduled prior to walking on the moon, and it was crucial to ensure that both the backpack would function correctly and that emergency egress procedures between the 2 spacecraft were also possible. Schweikert had no issues in his 1-hour spacewalk, during which he retrieved experiments from outside the crafts, took photos, and then ensured he could have re-entered the command module if necessary, though it wasn't, so he didn't. Day 5 of the mission was perhaps the most important of all. McDivitt and Schweikert boarded the LM, separated from Gumdrop, and the 2 were adjusted to maneuver apart, with the crew being tasked with bringing them back together again. The true significance of this lies in the fact that the lunar module cannot return crew to Earth. It isn't built to withstand atmospheric re-entry. So, for the very first time, astronauts were sitting aboard a spacecraft that they could not stay on for too long. When Scott initially pushed the button to separate the 2 craft, Spider clung to Gumdrop via the latches at the end of the docking probe. However, a simple second push of the button released them, and after 45 minutes, Spider was sent into a higher orbit to separate the 2 craft. They then spent several hours testing the descent engine at various settings, then dumped the entire descent stage while they were in a position to catch up with the command module again. Once they did, they spun the LM around to allow Scott to inspect it for damage before the 2 were docked together again. After 11 days of complete success, Apollo 9 returned to Earth on March 13, 1969. There was only one step left now. While it was completely unknown to US intelligence what the state of the Soviet space program was, it was in fact at this point in time not very good, the pressure, as far as they knew, was still on. Not simply to beat the Reds, but to honor Kennedy's word. It was time for Apollo 10. Apollo 10 was the F mission, a crewed flight demonstration of the LM and CSM in lunar orbit, performing all steps up to the final descent and landing on the moon. Effectively, it was a dress rehearsal for the real thing. While the LM being used was too heavy for a landing, much like the one from Apollo 9, delaying the mission by 1 month would allow for a landing-ready LM to be substituted. Mueller was always in favor of pushing the program forward as quickly as possible, but standing in opposition was the ever-practical Chris Kraft. He insisted that a rendezvous and docking needed to be attempted in lunar orbit before landing for the sole reason that the moon's uneven mass could throw off calculations when attempting to bring the two vehicles together. Program director Sam Phillips listened to the arguments on both sides and eventually yielded to Kraft, possibly noting that, as of late, the Soviet lunar program had been very quiet. US intelligence was largely unaware that, in the wake of Apollo 8's success, the Soviets had shifted gears to a single launch infrastructure utilizing their super heavy lift N-1 rocket, and it was going extremely poorly. The race was all but over, and for a brief moment, the Apollo program could, to a degree, take its time. The crew of Apollo 10 was announced in November of 1968. Thomas Stafford, John Young, and Gene Cernan. All Gemini veterans, the latter two would go on to walk on the moon on Apollo 16 and 17 respectively. Despite requests for professional names going forward, the crew named their command module Charlie Brown and the lunar module Snoopy. They had requested permission from the comic's creator Charles Schulz, who had given it, but felt uncertain given that Charlie Brown is often a clumsy failure of a character. The public, however, loved the name choice, so NASA used it to their advantage to boost public relations in regards to the Apollo program, which often clashed with the expenses and lives being lost in the ongoing Vietnam War. The full flight plan was as follows, according to Stafford. Our flight was to take the first lunar module to the moon. We would take the lunar module, go down to within about 10 miles above the moon, 9 miles above the mountains, radar map, photo map, pick out the first landing site, do the first rendezvous around the moon, pick out some future landing sites, and come home. The idea was to adhere as closely as possible to the plan for Apollo 11, which already had a general area for landing picked out by Apollo 8. In preparation, the crew spent around 5 hours in training for every hour of the mission, which lasted 8 days. If you don't want to do the math, that's about 960 hours, or 40 days. There's one aspect of Apollo 10 that's subject to some confusion, and I'll take a moment to address that now. There are some who believe that Apollo 10 could have made a lunar landing and only didn't because it wasn't in the mission plan. This is exacerbated by a subplot in the TV show For All Mankind, in which a fictional crew member of Apollo 10 also states to a news reporter that a landing was possible. However, it wasn't possible. The Ascent stage was only loaded with enough propellant to carry it from a lunar liftoff to about the point where it was supposed to fire anyway, about half of what was needed to put it back into orbit and make a successful rendezvous with the CSM. Historical writer Craig Nelson would write in his book Rocket Men that NASA had specifically chosen to have the fuel in the Ascent stage because they were worried that the astronauts might attempt a landing anyway. He quoted Cernan as saying, quote, "A lot of people thought about the kind of people we were. Don't give those guys an opportunity to land, cause they might." So the Ascent module, the part we lifted off the lunar surface with, was short fueled. The fuel tanks weren't full. So had we literally tried to land on the moon, we couldn't have gotten off. Mueller himself stated, quote, "They might have wanted to, but it was impossible for that lunar module to land. It was an early design that was too heavy for a lunar landing, or to be more precise, too heavy to be able to complete the ascent back to the command module. It was a test module, for the dress rehearsal only, and that was the way it was used." Apollo 10 was actually rolled to the pad before Apollo 9 even landed on March 11th. Being the first launch vehicle assembled in High Bay 2, this required it to loop around from the back of the VAB to reach the main crawlerway. It was tested on the pad for just over 2 months before lifting off on May 18, 1969. However, before we go any further, let's quickly tell a funny story. One day before the launch of Apollo 10, a man was pulled over for speeding by a police officer. When asked for identification, he admitted that he didn't have any on him. When he was asked his name, he began to get nervous, stating that he wasn't allowed to give it. Fearing an arrest, the man was saved at the last minute when another man pulled over nearby. He had recognized the man being questioned, and he introduced himself as Gunter Wendt, NASA launch pad leader. He explained that he was speaking to an astronaut who was scheduled to fly to the moon the very next day, and though the officer was skeptical, Gene Cernan was eventually let go without facing any charges. Apollo 10 made a familiar evil rear its ugly head: pogo oscillation. The Saturn V gave the crew a pretty rough ride on their way to orbit, but they made it without any significant issues. When the S-4B ignited again to send them toward the moon, the problem returned, worrying Cernan to a point where he wondered if they might have to abort, but the burn was completed successfully. Transposition and docking also went flawlessly, something washed from home since Apollo 10 was the first mission to carry a color television camera, and the crew settled in for their long voyage to the moon. After a fairly uneventful trip, the spacecraft was placed in lunar orbit just under 76 hours into the mission. After a second burn of the SPS to circularize their orbit, Stafford and Cernan checked out the LEM to prepare for its flight. When they opened the hatch, a cloud of fiberglass particles greeted them, shaken loose by the pogo oscillation problem during launch. They cleaned it up as best they could, but returned from the LEM looking, quote, like they just came out of a chicken coop, and would be scraping the particles off the air filter system for the duration of the trip. While incredibly annoying, Mission Control gave it a pass, stating that it shouldn't do anything to actually endanger the mission. The next day, Snoopy was separated from Charlie Brown, and John Young became the first person to fly solo around the moon. Cernan and Stafford deployed the landing gear and inspected the LM systems, while Young did a visual inspection through Charlie Brown's windows. Then the CSM performed a separation burn, and the LM performed a burn to begin a descent toward the moon. They passed over ALS-2, one of the proposed landing sites for Apollo 11, surveying and photographing it while they tested the landing radar. They came within 15.6 kilometers of the surface, then performed a phasing burn to allow them to pass the site a second time. As they prepared to drop the descent stage and return to orbit, near disaster struck. The LEM began to gyrate wildly, causing Cernan to remark, "Son of a bitch," into a hot mic that was being broadcast live, causing some complaints from the more prudish residents of Earth. 5 seconds after the tumbling began, the descent stage was jettisoned and Stafford fought to bring the vehicle under control manually. This took another 8 seconds, but they did manage to orient and fire the ascent stage properly, sending them back toward Charlie Brown. The unexpected motion of the LM was traced back to a switch that controlled the mode of the abort guidance system. Part of the procedure for the mission had involved moving this switch, but both crew members switched it. One switched it to the correct position, then the other unintentionally returned it to its original position. Nevertheless, the crew were able to successfully return and dock to Charlie Brown. After the crew boarded the CSM, Snoopy was jettisoned and its ascent engine was ignited one last time to send it into a solar orbit. It was the only LM to meet this fate, continuing to fly around the sun to this day, while the others were intentionally crashed into the lunar surface to test seismic experiments left on the surface, except for Apollo 11, which was simply left in lunar orbit. However, as we've covered, the moon's mass concentrations don't allow objects to remain in lunar orbit forever, so it too is long gone. Apollo 10 splashed down on May 26, 1969, a complete success. After about 2 weeks of data analysis, flight readiness teams cleared Apollo 11 to launch on schedule in July. In just 9 months, the Apollo program went from its first crewed flight to landing on the moon. The program stands, and will always stand, as a testament to what can be done when hearts and minds are in the right place. When bureaucracy and overly cautious safety concerns are set aside in the name of progress, truly incredible things can be done. When 500,000 people come together to design, build, test, refine, test again, and work like nobody has ever worked before, humanity begins to claim its birthright among the stars. While I was writing this script, spaceflight journalist Eric Berger tweeted out a happy 20th birthday to the Orion spacecraft. Originally built for the Constellation program, Orion has seen, in 20 years, exactly 2 uncrewed test flights. It pains me to see the way we've lost the ambition of the Apollo era. We have in recent years begun to make true strides again. Companies like SpaceX, Blue Origin, and others are beginning to revitalize the commercial market, and levels of reusability that the space shuttle only dreamed of are finally being achieved. We are on our way to a deserved future, but the heroes of Apollo would be disappointed in just how long it took us. In the space community, we like to joke that if we resurrected Wernher von Braun and showed him SpaceX Starship, he would be extremely proud of it, and then he would have a heart attack and die again when he realized it was not the 1980s. The road to the stars is a long one, but don't lose hope just yet. We're getting there.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.